Okay, welcome back. So you saw in the last video that we developed a very basic Python script to take a test protein sequence and to use it to calculate an overall average mass, right? Where we basically went through and we iterated over each of these amino acids, went and consulted the dictionary to get the amino acid mass, and then summed them all together and added the mass of the determinant water, right? So that's a pretty simple program and it works well, but we can make this more sophisticated in a couple of different ways. So first, let's write a function to catch some of the errors that may happen. So let's say calc AA mass, and we'll just take, let's call the variable just A. And so we could say, there's a couple of ways we could do this. So one, we could say if A in AA masses dot keys. Sorry, get that correct. Then we could say return AA masses A, right? So basically what this is saying is, let me just make this a little bit nicer. Before you actually try it, just say, is the amino acid actually in the list of keys, right? Because what we would get if we were to just run, say, like print AA masses of X, right? It's going to give us an error, right? It's going to say it doesn't have this key X. So what we can do is basically say, let's check first to see if we find it. And then if we do, we can use it. If not, let's just return 0, right? To basically say if we get an X, then what we could do is say calc AA masses mass of X. It's just going to return a 0, right? The other thing is like, I think what happens if we have a space in the middle of here? I think this will now, okay. Currently, as it's running, that's going to give us an error, right? Because it doesn't know how to handle the space, right? And that's basically because the space is not one of the keys, right? So I think now, if we go back and replace this to say calc AA mass, oops, it will detect that the space is not one of the known keys, and it will ignore it. There we go. So now if we go back to print total mass, there we go. So it's actually printing the correct value. We could also put in things like, a tab. Tab is a /t. You can see that it ignores that. If there's a new line, if you have various sort of spaces and characters or brackets or things like that, it's now going to ignore them and just say, I don't recognize that. You could also say, add in a print unrecognized character and have it print that off just so that you can see it in the command, in the line, so that if you have a tab or a bracket or something, that it kind of spits out that there's some unrecognized stuff there. Another good question is, what happens if you have a lowercase value? It's not recognized. So one of the ways we can do this is you could say a.upper. Basically what that'll do is it'll say make everything capitalized, right? This would be a way that you could essentially recognize, if we were to replace that L with a lowercase l, it'll still work, right? Because what it'll do is basically capitalize everything. And there's lots of cool things like this that you can do with Python. So for example, like if you wanted to calculate in this sequence how many lysines there were, you could do print testseq.count k, right? And that'll tell you there's 17 lysines. So there's lots of stuff that you can do in Python that could be useful. Let's go back and put that in. Let's see, what other potential things do we want to do? Okay, so another thing we might want to do is to calculate basically monoisotopic masses rather than average. So these are average masses that I put in. Let's go ahead and make some monoisotopic versions of these. So we'll do mass water monoisotopic. Paste that in. You can see it's not that different, but it is a little different. Let's go ahead and paste in, and I've created all these separately for you. those are the monoisotopic mass dictionary. So you can see they're very similar, but just slightly off because they're monoisotopic. So there's a couple things we need to do. One, we need to put in a test here to say, or put in a variable to say monoisotopic, right, equals false. And let's say monoisotopic equals false. This just basically says the default is for it to do average, right? And in here what we can say is if monoisotopic, return AA masses monoisotopic of A, else return this. So the way this function is working is that it basically first capitalizes all the variables, then it says if it finds that variable in the list of keys, which is just the list of all these letters, it will then go on and check if the flag says it's monoisotopic, return the value from the monoisotopic dictionary, otherwise return it from the average dictionary. And if it doesn't find the character, it just prints something and then returns a 0, right? Here we just need to now feed this in to say that equals the variable here. So basically now we can say monoisotopic equals false, equals either, if we say false here and run it, it's going to return the same value, right? Because it's basically passing this variable down. So if we don't have anything here, we just take it out, it's also going to return false, or it's going to return the average because we've told it all along that the default is false. If we go back, let's change this to true. You can now see we're getting a slightly different value because it's printing out the monoisotopic mass rather than the average. So yeah, this is basically a way, when you put in these different variables, it's a way of feeding information down and creating new variables. And we're just basically providing a default. We could leave the default out and then force the user to tell it, but I kind of like to always provide a default because I think you know, users kind of want to be able to just say test seek and get a value, and then putting in additional options is, you know, can add additional stuff. There's one slight difference though. If monoisotopic, we forgot to do the water mass. There we go. So we're just going to now create the water variable here, and this should be slightly different because basically now we're using the monoisotopic water mass rather than the regular average mass. So this video now gave you some useful tools to basically go through and fix some potential errors that you might get in your function to add in monoisotopic masses. Now, there's a lot of ways that you could extend this. So you could think about you know, maybe you want to add in the ability to put in a pyroglutamate, and then you could sense if there's a, you know, a particular glutamate residue here, you could flag and change the mass. I have in my version ways that you can add disulfide counting, so you can look for if there's disulfides. And another thing you might want to do is that you might want to calculate this for an RNA or a DNA, right? So an oligonucleotide. And for those, I can go ahead and paste in, these are the RNA and the DNA dictionaries. You can go through and write the functions that you want yourself and think about the different termini that you want to put on them. You could also think about putting in unnatural amino acids, right? Like phosphorylated residues and things like that. You could just put those in as individual character counts here. Now here's where you might need to be careful. There's only 26 characters that are capitalized, right? So if you want to start adding in more than that, you might want to take away this upper so that you could use lowercase residues, right? So you could use like a lowercase t as a phosphorylated threonine or something like that. Because the way that this is going to work, if you look at this function, it's looping through all individual characters. So you can't put in like a 2-character sequence with this particular way of doing it. What you could do though is add in like a find and replace to say every time I see like a PT to just take that out and put in a lowercase t. And you would do that with I think the string.replace segment. if you want, that would be a good thing to work on for your homework. So try that, test that out, and see if you can figure out if you put in like a PT, how you would calculate a phosphothreonine or something like that. Yeah, so there's lots of different things you can do with this. Try them out as homework assignments and see where you can go. Have fun.